Hello, I am Aidan Wu. Today we are going to discuss an important topic. Can datums be assigned to centerlines? We often see some engineers assigning datum to a centerline, and then referencing that datum for other geometric tolerances. Is there an issue with this approach? In other words, if we use this annotation shown here, will it cause problems during manufacturing and quality control? We need to carefully analyze this issue. Let's start by removing all the annotations and then analyze it from a microscopic perspective. The parts we see on the joints or in CAD software are perfect, as shown in this diagram. This model is called a nominal model. The actual part that we manufacture during production is called the actual model, which, as you can see, is an imperfect model. Note that the dimensional and geometric tolerances we specified on drawing are applied to control the actual model or the actual part. If the actual part is as shown, then when we assign datum A to the center line, which axis does datum A refer to? It could be the axis of the minimum circumscribed cylinder at the smallest condition, axis A1, or it could be the axis of the minimum circumscribed cylinder at the intermediate condition, axis A2. Alternatively, it could be the axis of the minimum circumscribed cylinder at the largest condition, axis A3. So here's the problem. We have three different axes. Which one does datum A actually refer to? Should we leave it up to the inspection engineer to decide? It is important to note that A1, A2, and A3 are completely different axes. If we select different axes as the datum, the measurement result will definitely vary. Therefore, this kind of drawing annotation is non-compliant, and the definition is unclear. It doesn't satisfy the principle of the unique interpretation for the drawing. So, how should it be correctly defined? Let's assume the designer wants to use the axis at the intermediate condition as the datum. We can start by specifying the size tolerance, and then place the datum A below the size tolerance, or on the extension line of the dimension area. Other geometric tolerance can then reference this datum. This way, the datum definition is very clear. The design intent is very specific. Datum A refers to the axis of the minimum circumscribed cylinder at the intermediate condition. This ensures that both quality engineers and manufacturing engineers will not have any misinterpretation when reading the drawing. There are many similar errors. For example, in this drawing, datum B and datum C are assigned to the center line. In a larger drawing, datum A are assigned to the symmetry line. These annotations are incorrect, especially for the inspection engineer. It's unclear which feature should be used to establish the datum. This can lead to the disputes between suppliers and customers, as well as different departments within the company. It reduces communication efficiency and causes losses for the business. So, when design engineers create drawings, they must follow one key principle. clear and ambiguous definition. What does clear definition mean? You may ask yourself, is my annotation compliant where it causes any ambiguity for manufacturing or quality engineers? In other words, as a design engineer, you must avoid making downstream manufacturing and quality engineers guess your intent. Don't leave any room for subjective interpretation. This is what we mean by clear definition. Do you understand it?